In our last two videos, we saw type 1 and type 2. In this video, we will be seeing type 3. So let's get started. Before starting, please have a look at these formulas as we may need this in this video. Before studying our type 3, at first let's have a look at these two examples. The first problem is integration of sine inverse x. Now, we don't have any formula for sine inverse x, but we have formula for 2 sine inverse x, right? So let us bring a 2 here by writing 1 by 2 here. So we used the formula 2 sine square x equal 1 minus cos 2x. So we separated the two parts and then we just integrated. And integration of 1 gives us x, and integration of cos 2x gives us sine 2x divided by 2. So we already had 1 by 2 in the front, so multiplying that half with the integrated parts gives us x by 2 minus 1 by 4 sine 2x plus c. Now in the second example, there is integration of sine 3x cos 2x. Now we can see that we don't have any formula for this, but we have a formula for 2 sine a cos b, which is sine a plus b plus sine a minus b. So let us just apply there by bringing a 2 here extra by writing 1 by 2. So now we have 2 sine a cos b, so we applied the formula sine a plus b, which is sine 3x plus 2x equal to sine 5x plus sine 3x minus 2x equals sine x here. Now we just separated the two parts and then we just integrated it. And integration of sine 5x gives us minus cos 5x divided by 5. Here you need to remember that whenever in the angle part with in any trigonometric function we have something as coefficient with the x, we have to write it after integrating in the denominator. Here it is 5, and in this case it is 1. And integration of sine x gives us minus cos x, and we had 1 by 2 in both the parts, so we wrote it in the front, and at last we have to write plus c. Before studying our type 3, which is method of substitution, have a look at these formulas as we may need these formulas. In our type 3, we will basically solve a few of these problems, so let's get started. Type 3 is method of substitution, so we have to consider some part of the given question as our z. Now which part should we consider as our z? We have to consider such a part as our z that differentiation of which gives something which is already present in the question. For example, if we assume sine inverse x as our z, now differentiation of sine inverse x gives us 1 divided by root over 1 minus x square, which is also present in the given question. So we can assume sine inverse x as our z. Now in some cases it may be confusing, so you can follow this small trick, which is LIATE. Here L means logarithm, I means inverse circular function, A means algebraic functions, T means trigonometric ones, and E means exponential. You have to go from L, then I, then A, then T, then E. It means for assuming Z, if there is any logarithm part in the given question, you can assume that part as our Z. If any logarithm function is not present, then you can consider for inverse circular function, which is the thing which we actually did in our last example. And if inverse circular is also not present, then algebraic, and that is not also present, then we can go for trigonometric, and lastly exponential. So we have to go from left to right in this way. Since any logarithm part is not present in the question, but we know after L comes I, which is inverse circular function. Here inverse function is present, which is sine inverse x. So let us assume this part as our z, and also differentiation of this gives us 1 divided by root over 1 minus x square, which is also present in the given question. Now we differentiated sine inverse x equal z, which gives us 1 divided by root over 1 minus x square, and in the right side we get dz by dx. So we brought the dx part in the left side so that we can find the value of this part which is given in the question in terms of z. Now let us put the value in terms of z in this question. So integration of e to the power a sine inverse x, which is basically e to the power a z, since sine inverse x means z. And this part, as we just calculated here, this part gives us dz. So our question, after expressing it in terms of z, it gives us integration of e to the power az dz. Now we know integration of e to the power az is basically e to the power az divided by a plus c. Lastly, we have to just replace the value of z with the given thing which we assumed a bit while back, which is sine inverse x. So we have written sine inverse x in terms of z, so this is our answer. Now your task is to do number 2. Now let us start number 3, which is integration of sec x divided by log sec x plus tan x dx. Now as we have to assume z, which part should we consider as z? The log part, right? Since according to our LIATE, log comes first and also the logarithm part is present here. So let us consider this log sec x plus tan x equal to our z. Now if we differentiate, we know differentiation of log x gives us 1 by x. So differentiation of this gives us 1 divided by sec x plus tan x, and according to our chain rule, sec x plus tan x gives us sec x tan x plus sec square x. And in the right side we have dz by dx, and if we bring the dx part of the denominator in the left side, we get this. We just brought the denominator dx to the left side. Now we have taken sec x as common, so we have sec x into tan x plus sec x, and since we have the same thing in the denominator as well, so we can just cancel it out, sec x plus tan x. So we cancelled it out, and now we have sec x dx equal dz. Now our turn is to replace these things in the question in terms of z. Since we have got the value of the numerator part sec x dx in terms of z, which is dz, so we put the value in the given question in terms of z. 1 divided by log sec x plus tan x is 1 divided by z here, and in the upper part we just found the value, it is z. Now integration of 1 by z gives us log z, so lastly we just replace the value of z, which is this log sec x plus tan x, and at last we have to write c. So that's the answer. Now let's have a look at our last example of type 3, which is integration of e to the power x 1 plus x cos square x e to the power x. Here in this case we will consider x e to the power x as our z. Why? Because differentiation of this part gives us the above part. How? Because we can apply the uv formula here. If we consider our x as our u and e to the power x as our v, we will get this, because because the formula is u ddx of v plus v ddx of u, which is x e to the power x plus e to the power x into 1. And in the right side we have dz by dx, and we brought the dx of the denominator in the left side. Now we have ex 1 plus x dx equal dz. So this way we found the value of our numerator, this part, as our dz. Now let's put the value in the given question in terms of z. In the numerator part we got dz, so we wrote dz, and in the rest part we have 1 divided by cos square x e to the power x, which is basically 1 divided by cos square z, and integration of 1 divided by cos square z is tan z. How? Because 1 divided by cos square z is sec square z, and integration of sec square z is tan z, and at last we have to write c, and finally we have to replace the value of z, which is x e to the power x. So that's the end of type 3. Hope you have understood.